So I'm going to talk about Netflix OSS, and my goal today is to help just give you guys a quick tour of some of the tools and that allow you to build and deploy applications to the cloud using Netflix OSS. I can't go over everything Netflix OSS provides because we have a lot of projects. This doesn't even cover it. This is a picture I took a while ago. So we're going to give just a small taste of some of the patterns and tools we use. Some of the tools my team owns, some of them we don't. And hopefully this will be useful for you guys. AWS, we're going to be building on top of AWS. All of Netflix Cloud runs on AWS. And our goal today is going to be 4 steps. We're going to stand up a quick Netflix cloud, Netflix OSS cloud, build an app, deploy to the cloud, and hopefully profit. So the foundation for this talk is going to be a tutorial that we put together called Zero to the Cloud. You can actually, this is a GitHub project. The intent of this project was to show people how to stand up the core infrastructure for Netflix OSS. I already did most of this work because it took me a few hours just to run through this tutorial. It was a half-day tutorial we would run at OSCON, but it provides you some foundations. If your AWS account, it sets you up with a jump host that enables you to securely log into your cloud. And then we set up foundation AMIs, the base AMI, Asgard, ETA, and Eureka, as well as some other bonus features down here. So I'll cover some of these in detail in a minute, but first, I'll come back to some of these concepts in a minute. So to build our app, we're going to use a Spring Boot. How many people use Spring Boot before? Okay. So I don't know how many Java developers are here, but Java, tends to be verbose. Spring Boot kind of brings a cool approach to building Java apps. In order to do that, you guys can clone this GitHub repo. It's a very simple Spring Boot app. I haven't done anything other than make it a little less terse from the basic Spring Boot app and run Gradle. So let me show you that code right here. So this is all the code for the Spring Boot app we're going to use. This is actually in Groovy. This is Java annotations, and essentially just has one endpoint on the root called Hello World. Important for this demo is the build script. So like I'm the build tools team manager. We provide build scripts and build infrastructure for the rest of Netflix, and this is a Gradle build. So we use Gradle as our core build application, and Gradle has a couple of functions, including we have all these plugins here that tells us that this app is a Groovy-based app, it's Spring Boot-based, and has a plugin that allows us to create an application. There's not really any magic here other than saying we're going to use Java 7, the version of the app. And here, Spring Boot allows us to create an application and run it just as a Java main. So it kind of gets us away from depending strictly on containers like Tomcat. So to run this, we're going to run Gradle. Now you could run Gradle W like this. I also you'll see me type GW. GW is just an alias I have for local Gradle W call. And Gradle W is the Gradle wrapper. So it allows me to bootstrap an application, give you this code without having to have access to the Gradle binary. So this app is now up and running. And as you can see, it's just returning a very simple hello world. So nothing magical, nothing special about this app. All right. So the next step is we're not going to run it in the cloud as a Java app. We're not going to run it as a Java main app. We're going to convert it to a WAR, and we're going to run it in a Tomcat container. So I'm cheating a little bit because I'm scared of live demos. So I'm going to show you. I have all my steps prepped as Git branches. So this allows me to switch to these branches, and then I'll show you the code changes. So to convert this to a WAR, all we have to do is apply this plugin WAR. And Spring Boot just requires that we add a couple of changes to our Gradle build here. telling it that this is going to be a Tomcat app running in the container rather than as a main class. The other thing that I did was it just added a Spring Boot servlet initializer. So this is the only change we're going to make this a container app. So now, before, when we ran the build, So if we run just the build now, instead of producing just a Java class and running that locally, we're going to get a WAR file. So this is still nothing outrageous or anything crazy. But we're going to take that WAR file, we're going to deploy it to the cloud now. So now and in order to do that, Netflix applies a thing called the immutable server pattern. Has anyone heard of this? Okay, a few of you. The immutable server pattern means that whenever we deploy code to a server, we never ever touch an existing server. Whenever we want to deploy code to the cloud, we're going to create a new VM image, and then we're going to destroy the old image. So the process I'm going to show you now is how we go about creating new VM images or AMIs, put them in the cloud, and then we scale those up. And this allows us to avoid things like configuration drift. It allows our build pipeline to be much more repeatable. And it looks something like this. We start off with code, and we turn that code into an OS package, a Debian package, in this case, but you can turn it into an RPM. From there, then we take that Debian package and we bake it into an AMI, and I'll show you what that looks like. And that AMI is now our unit of deployment. So that WAR is only an intermediate step to creating a Debian to creating an AMI. The AMI, an Amazon machine image, is what we use, and Amazon will store for us, and then we scale that up into maybe one or tens or hundreds of instances. When we make and that ELB will route traffic to that ASG, or that auto-scaling group in Amazon. Like I said, we make a code change, it's another instance of this pipeline where code is turned into another Debian, which is pushed into, in our case, in a Yum repo. And then another AMI is built, and then another ASG is scaled up based on that AMI, and we route traffic to that new ELB. That old ASG will keep around for a while, and that allows us to switch traffic back if something's wrong with that new ASG, which is a switch. So this allows us a fast rollback as well, this pattern. So to do that, we're going to use the first Netflix OSS project I'm going to show you, which is Nebula. So Nebula is a set of Gradle plugins that our team has built. Even though they're in Gradle, they're intended for use for all Netflix applications. The majority of the applications at Netflix are Java-based. You have, as well as some Scala-based applications, which are also JVM-based. But also our Node teams and Python teams will also use Nebula to deploy their applications in the same manner I showed you before. So to do this, we're going to take a project called OS Package, and it's a Gradle plugin, and then we're going to run a clean dev build dev. So just like before, I'm going to check out the package as a deb project, and Gradle now gives us new tasks. So we have these build deb and build RPM tasks. And how the build script looks now is we have this new plugin called OS Package. And there's for those of you who aren't familiar with Gradle, this build script merely is think of it as a class path to bootstrap up. The build script section is a class path for bootstrapping up any plugins for that build. So we needed to add a dependency on this OS Package plugin. There are other ways to do this, but for the purposes, we're going to just do it this way. So now that we have OS Package and we have this build deb, we need to tell Gradle what do we want inside of this Debian package. And this is where OS Package kind of really shines. So we have this OS Package block, which allows us to define a couple things. Right here, we're defining for the Debian that we're going to produce that it requires the default JDK and Tomcat 7 to be installed on the machine for this Debian to be installed. And then in addition to that, we're going to take the WAR file. So this is a groovy DSL inside of Gradle. Take that WAR file and explode it into the Tomcat web apps directory and rename it to root.war, which is a convention for Tomcat. It's just saying this is the default app deployed in this Tomcat container. And then one last thing we're going to do before we install this app, we're going to remove the root directory, the existing root application that comes default with Tomcat. That way that our application gets installed and deployed rather than the root app. All right, so now we'll just run build deb. And then in our build directory, which is the output, you can see we have some new files. We have the Debian package. We still have that war file sitting there, but inside of that is our deb. And then we have all the control files and pre and post install scripts sitting right there. So you can look at those if you want to. Let's see, the pre-install. So here you can see we declared that we want to remove that directory beforehand. So when this Debian installs, it's going to remove this directory. All right, so now we have a deb, and having tried to make this work and deploy, I highly recommend doing the next step, which is test your deb with Vagrant. So the lifecycle of getting this Debian package into the cloud, getting the Emulator to bake, which I'll show you in a minute, and then scaling up to test your deb is going to take longer than you want. You're going to want to test with Vagrant. So how many people have used Vagrant before? Okay. So enough that I need to explain it probably. So Vagrant is a wrapper around VirtualBox that allows you to define in a DSL how to boot up a local VM. And I can save this in a Vagrant file. So I'll show you that right here. So now that I've switched to that branch, I have in this project now a Vagrant file. And this Vagrant file tells us that we want to stand up a trusty 64, Ubuntu trusty, we want to open up some ports, and then we want to, because we're defining these pre-installs, or defining these dependencies, I'm going to have the Vagrant project, Vagrant install these before it installs my deb. So I'm telling it to just open up a shell and do these things when you boot up the Vagrant instance. Normally, if this is the first time you're running, I'll do a status, and it tells me that Vagrant has no instances running, so I'll just do Vagrant up. Now this is going to take a while, and I'm probably not going to let it finish, but we can, let's assume this runs in the background and works perfectly. The next step is going to be push our deb up onto the jump host. So I mentioned the jump host earlier. So the process for today's demo is we're going to push our deb project onto the jump host, which has Emulator installed, and then I'll explain. Once I'll show you what we're going to do today, I will tell you how we do this at Netflix. So you don't think that this is how we do things every day at Netflix. All right. So what I'm going to do is SCP this file onto our jump host, which I've just aliased here for simplicity's sake. And then we're going to SSH into that host. And sitting right here is that deb file. Now, before I do anything with this, I'm going to talk about Emulator and how we create base AMIs. All right. So our process for creating an AMI looks like this. The vendor will release a new version of an OS, and we'll take that and we'll save that in our cloud as a foundation AMI, which you see on the left here. Then we have a base AMI install process, which in this case I'm just demonstrating as a deb package. So you might have a deb that represents the core components of every single AMI that you want for every single instance that you deploy in your cloud. So here we're just saying, just install default G80K and Tomcat 7. So this pipeline right here will then create a base AMI. When I want to deploy my application, I'm going to take my AMI up here, which is the Hello World one, and I'm going to then map it to the base AMI, and that's going to create my application-specific AMI. All right. So this is what we're going to do. So when we run, in order to do this, we're going to use a tool called Emulator. There we go. So can you guys see this? Actually, let me move that to the top. So Emanator allows us, is a Python script that allows us to say, take the base AMI, which is this AMI here, which I've already created beforehand, and install this deb. And what this is going to do is it's going to mount that AMI locally, and then it's going to install the deb in there, and then once it's done, it's going to use the Amazon APIs, and then save that into the cloud. So now I kind of have two things going in parallel. You can see Vagrant is still doing its magic, and I imagine it's going to go a little slower because of the network. And then we have Emanator right now running the cloud, creating an AMI for me. So while these things run, I'll explain to you what we're going to do next. So this is, if we were to wait, and in case doesn't finish successfully, this is what the output would look like from Emanator. And the key here is right here, which you can't really see, which is this AMI name. So this is the name of the AMI that has been built and stored in Amazon. And we're going to use this for our deployments in a minute. So the last step of deploying an application is to stand up an application in Asgard. Has anyone used Asgard right now? Anybody? Okay. So Asgard is our cloud-based deployment application. Now, it's pretty old at this point, and Netflix is sunsetting Asgard this year. So I'm showing you this, knowing that I might be the last person at Netflix to ever show a presentation including Asgard. But it's awesome UI. Shouldn't make fun of it. It's done great things. And so Asgard is a Grails app that sits on top of AWS, and it provides two key pieces of functionality. One, which is if you're deploying in AWS, you have to manage AMIs, launch configs, security groups, ASGs, ELBs. All these things you need to join together to create what you would think of as an application. I'm building a Hello World application. I need to map all these things together. Asgard allows us to create this abstraction on top of AWS and deploy applications to the cloud. So here we're creating an application using Asgard. We would go through and then create security groups. So we would just create a security group for our application in the VPC. Then we'd create a new load balancer, and the trick is you have to point it to a health checkpoint down at the bottom. So when Asgard boots up this AMI, it needs to know whether that AMI's application is good or not. And so we point it just to a health URL. And then we create an auto-scaling group. And the trick there is in the dropdown for the auto-scaling group, you'll see a mapping of the AMIs that are available to you, and you'll pick the AMI that you want for your application. So let's check on, so it's still, Emanator's still taking a snapshot, and looks like Vagrant's done. So Vagrant now is up and running. And so we could, oh yeah. So I configured Vagrant to use port 8081. And we can see the health checks URL for that is not available because I had a typo. So that would be status is up. All right, so let me show you Asgard real quick. So this is Asgard. And as you can see, I already created a few applications in the cloud for Asgard. Hello World, Asgard is actually managing itself. So in theory, when I want to deploy a new version of Asgard, I would go to the Asgard, and I would go to the cluster view, and you can see, I would choose Asgard, and you can see that I have already two instances of Asgard. I have an old instance, which is right here, which is version 000, and the one that's currently running. This ASG here has an instance available, but no traffic is going to it. And this one has traffic going to it. If I wanted to switch, I would click Enable and go back, and I could disable. So I could roll back traffic to that old instance, and hopefully I haven't ruined my demo by doing that. So now now all traffic would be running against this old app instance of Asgard. And so I'll switch it back. and disable traffic on the old one. And then now we're using the new version. Okay. So as part of our application deployment, we're going to be deploying Hello World. So Aminator completed, and as you can see, it finished creating this AMI right here. So we're going to copy that, and we're going to go to our Hello World application. And here we have one instance running, one ASG running with only one instance. And this box over here is where most developers, when using Asgard, would spend most of their time. This is where we're going to tell it to create a new instance of our ASG. So we want to show all the AMIs, and these are all the AMIs that are available right now. And that list is very long when you imagine that we're doing deployments. Multiple teams are doing deployments every single day, so the search box is critical. And as you can see, it's telling me it hasn't found it yet. So I found that it takes a minute or two for AWS to recognize. Okay, so we can go off an old ASG if that's going to take a while. So we'll do this one, or old AMI. So we're telling it how many instances we want, and then we'll click Create Hello World version 1. So now what we have is we have two ASGs for this application, the old version and the new version. This instance is still booting up, and so traffic is being routed to the current instance right here. And this ELB icon points us to where all the traffic is being routed from the ELB. So if you want to see this application running, you could see there's this Hello World, right? So this is running in the cloud right now. And you can see that Asgard provides us a view that you can see that this is in service. So it actually is going to wait. It's not going to route traffic to an instance until that health check comes back and completes. So then, all right, so let's go back. Okay. So when most applications, I just showed you deploying an application behind an ELB. Most applications or most services at Netflix aren't behind ELBs. They as each instance is boots up, it registers itself with a thing called Eureka. So Eureka is our discovery service, and that is also open source. Interestingly enough, when you check out Eureka, it's not also another aging piece of software with an aging UI. So, but Eureka is an amazing piece of software. So we have Eureka instances in every single region, and all health checks go through there. So if I'm on service A and I want to discover an instance of service B to make a call, I'm going to call out to Eureka and say, give me all the available instances that are registered with you of service B, and then I'll pick one and make network calls to that. So we want to be able to get our application now to register with Eureka. And it's actually fairly simple thanks to Spring Cloud. So our applications, the demo I'm showing you is, let's see here. We're pulling in a new library here called Eureka Client. And this one annotation, what we add, one import statement, one annotation, when we load up our application, it's now going to register itself with Eureka and make itself available. We also had to add one other thing, actually, which is a YAML file that points to the location of the Eureka service. So in production, you'll probably have it point to multiple instances. So now, if we go back to Eureka, you can see that this IP right here of this instance is registered. Okay. So, yeah. I don't think I'm going to spend too much time talking about Eureka after that. So in order to do that, we'd have to go through this. Once we made that code change, we have to go through the build cycle, build a new deb, bake that deb, and then deploy that to the cloud. Okay. So this is a really quick tour of how you would build, bake, and deploy with using Netflix OSS. But this is just the beginning. I don't recommend running your full cloud in the setup that as the zero to cloud intro shows you. Definitely recommend beefing up your security. We don't SCP files up into the cloud. So we use continuous integration, and then we publish our AMIs to Artifactory, and we publish our debs to Artifactory or Yum repos in Artifactory. And then we actually have a service called the Bakery, which we have not open sourced. And the Bakery are RESTful APIs that sit on top of Emanator that run in each region. So when I produce my AMI and I push it into Artifactory, I tell the Bakery, I make a RESTful call to the Bakery saying, go bake this deb in this region using this base AMI. And it will do that for me, and then it'll tell me when it's done. The Zero to the Cloud also provides an introduction of how to set up the Simian army, so you can set up Chaos Monkey, Janitor Monkey. Just going through this exercise this weekend, I already accumulated probably 10 AMIs, only 4 of which I'm probably using. So Janitor Monkey would go in there and just clean up the old ones. And of course, Chaos Monkey would go in there and kill instances. Most of the time, I only showed you how I'm running applications, one instance of an application per ASG. In production, we have a rule of 3. That each ASG should have at least 3 instances running. So right here, where is it? So I would have 3. And honestly, to get this up to 3 instances, I would just have to say resize. And what it will do is, and I will just resize this down to 0. So it's going to scale up. It has 1 instance serving traffic in this region, or this ASG, and it will start building 2 more. Okay. So there's also a Zero to Docker that we've created. This is a way for you guys to test some of the Netflix OSS in Docker locally. And eventually, we're going to plan on beefing up the Zero to Docker as well as the Zero to Cloud setup, and make it much easier for you guys to build applications. I plan on taking some of this Spring Boot application and putting it into the Zero to Cloud. So I would check back with the Zero to Cloud project and see if we've made any progress on, or give us any feedback, add issues in there. And also, if you're interested, the Build Tools team, we're hiring at Netflix. So come see me afterwards. I'll stick around. I'm not going to be here for the rest of the week. Unfortunately, I have another conference to go to. But hit me up on Twitter. Thank you. All right.